My name is Virginia Canestraight, and I'm a second-year graduate student in the Harvard C School studying material science and mechanical engineering, and I work in Zachary Schiffer's lab. This is what's on my bench. I am an electrochemical engineer, and to me that means connecting the electric grid to important chemical transformations. And the way you encounter this most often is probably thinking about batteries, which is where we most directly see electricity stored as chemical energy, but we can additionally use this to make molecules. This is something that oftentimes people call chemical engineers glorified plumbers because we do so much work with piping. And, by carrying around a wrench all day in lab, I feel like I really live that out. Most often, I'm just using the wrenches to tighten gas fittings. When I tighten gas lines, really what I'm doing is allowing us to flow whatever reactant we want to our reactor. This is oftentimes mixes of nitrogen, hydrogen gas, and sometimes organic compounds as well. So this is an electrolyzer, and that's just a fancy word for the device we use to run current through our chemical reaction. It's a special device to me because I got to design it when I joined the lab. We do a lot of work that happens at higher temperatures, somewhere between 100 and 300 Celsius. And most electrolyzers for research applications that are engineered devices are made out of plastic. It's very convenient and easy to prototype. Our lab has 3D printers, but all of those materials will melt. So this one's carefully designed out of stainless steel and one of my favorite materials called Kapton. And this is where I run all of my reactions. Next up is my sign. It's a quote that says, "All models are wrong, but some are useful." And this is commonly thrown around by statisticians, but it's something that I really believe in, especially in an electrochemical engineering context. The reactors we use are extremely complicated, and it's hard to know what all is going on. So we oftentimes use computer modeling to help understand some of the important physics that is at play. Now, it's easy to just go on your laptop and run away. You can make anything happen on your computer, but it's only important if it can translate into a real-world application or actually work to make your real-world reactor better. So as someone who uses modeling tools a lot, it's a really important reminder for me to keep all the models that I create ground into something that's actually useful in lab. Last, we have my notebook. So this is, pretty simple. Most scientists have a lab notebook around. This one for me was when I finally decided that paper wasn't a sacred material and I could just write down anything I needed. So instead of continuing to search for scrap paper, now everything gets written down in here. I'm very excited because I just started a new one, which meant I got to add a new color to my collection. Additionally, I think it's fun to kind of flip through the pages and see what my year was like, because you'll find planning for craft projects and quilts right next to lists of lecture notes for condensed phase physics. I'm really excited to see all my projects taking shape as I go into the later years of my PhD, and I really hope that we're able to demonstrate that electrochemistry can kind of unseat typical industrial processes and offer a much more energy efficient way forward.